Right. In this video, we're going to be looking at theory for pair of linear equations in two variables. The theory, we have actually broken it down into four parts. The objective being twofold. One, the video does not get too long. Two, we'll be able to give a lot of attention to each of these parts. We're given breaks at logical points where we can consolidate what you have learned in each part before we move on further. In the first part, we're going to be answering the following question. What is a linear equation? Let's come to pair of linear equations subsequently. What is a linear equation? Second, let's move on to what is a linear equation in two variables represent geometrically. What is the graphical significance, geometrical significance of it? Then subsequently, let's move on to what is a pair of linear equations in two variables represent geometrically. There are three possibilities that come with it. Let's discuss all three possibilities in this video. Let's answer the first question. What's a linear equation? Any equation in which the power of all the variables is 1 is called a linear equation. How many variables can it have? Absolutely no limit to it. You can start with as less as 1 and you can have any number of variables. It could be a linear equation in one variable, as in this example. Look at the power of x is 1. So it's a linear equation. It could be a linear equation in two variables, 4x plus 7y equals 90. The power of x is 1, the power of y is 1. So it's a linear equation in two variables. Our focus in this chapter is linear equation in two variables. In specific, we'll be looking at a pair of linear equations in two variables. Let's start with this. We can also write this equation. You'd see it written more often than not this way as well. 4x plus 7y minus 90 equals 0. Both mean one and the same. Or you can have a linear equation in three variables and so on. Let's start with a linear equation in two variables. Let's look at this example. 10x minus 4y equals 20, or take the 20 to the left hand side. 10x minus 4y minus 20 equals 0. How do we represent a linear equation in its general form? This is a linear equation in two variables. How do we represent a linear equation in two variables in its general form? We'll write it as ax plus by plus c equals 0, where a and b are not both 0. Let's come to this in a while. We'll look at this equation. In this equation, a equals 10, b equals minus 4, and c equals minus 20. So generalized form of equation is ax plus by plus c equals 0, where a and b are not both 0. Maximum of 1 can be 0. It would basically narrow down to an equation in one variable, but you cannot have both of them as 0. It's usually represented, that information, as a square plus b square is not equal to 0. Square of a number is not negative, so a square could be a 0 or a positive number. B square will also be a 0 or a positive number. Essentially, we are saying if both of them are 0, then the sum will be equal to 0. The sum of these two is not 0. At least one of these numbers is not 0. So the coefficient of both x and y cannot both be 0 is what we are saying. Let's start with this. What happens when you substitute, let's say, an x equals 4 and y equals 5 in this equation? Just pick some numbers to see what happens. 10 times 4, the LHS is going to be 10 times 4 minus 4 into y is equal to 5. 4 times 5. 10 times 4 is a 40. So we have 40 minus 20, which is equal to 20. What is the RHS? RHS is equal to 20. Is LHS equal to RHS? Yes, LHS is equal to RHS. So when I substitute x equals 4 and y equals 5, it basically validates this equation. We'll say that it is satisfying this equation. Let's look at one more example. What if x equals 2 and y equals 5? Let's find out the value of the LHS in this case. LHS in this case will be 10 times 2 minus 4 times 5. 10 times 2 is a 20 minus 4 times 5 is a 20, which equals 0. The RHS we know is equal to a 20. LHS is a 0, RHS is a 20, so LHS is not equal to RHS. So 2, 5 does not validate this equation. We'll say that it is not satisfying this equation. So when I substituted a 4, 5, the LHS was equal to RHS. We said the values satisfy the equation. 4, 5 satisfy the equation. 2, 5 did not validate. LHS was not equal to RHS. We'll say that the values do not satisfy the equation. Now let's go from here and check out what is the geometrical significance of it. Let's start with the equation itself. 10x minus 4y minus 20 equals 0, or 10x minus 4y equals 20. What does it represent when you plot it on a graph sheet? What's the geometrical representation of it? A linear equation in two variables represents a straight line. Now let's look at that point 4, 5. What does that mean? We knew that 4, 5 satisfied this equation. What does this 4, 5 look like, these values? It looks like coordinates of a point. So if 4, 5, when I plugged it into this equation, it satisfied it, and we know that this is the equation of a line, then it essentially means that 4, 5 are the coordinates of one of the points on this straight line. So 4 comma 5 satisfy the equation. Then the point 4 comma 5 lies on this line 10x minus 4y equals 20. What does it mean when we say 2 comma 5 does not satisfy this equation? It essentially means that if I substitute 2 comma 5, it is not validating this equation. It's not satisfying this equation. This is an equation of a straight line. Any point on the straight line will validate the equation of the straight line. So if it is not validating, it's not going to be a point on the line. So 2 comma 5 does not lie on this line. 4 comma 5 lies on this line. Let's quickly see it. We've seen this algebraically. Let's plot it on a graph sheet and check out what happens. This is a line 10x minus 4y equals 20. Let's look at this point. We had this point 4 comma 5, right? X equals 4, y equals 5. This is the x-axis, x is 4, y is equal to 5. Is it lying on this line? It satisfied the line. 10 into 4, which is 40, minus 4 into 5, 20. This equals 20. So LHS is a 20, RHS is a 20. We realized a little while ago, 4 comma 5 is a point on the line. It satisfies it. Let's pick one more point. Let's pick this point. What are the coordinates of this point? X coordinate is 0, y coordinate is equal to, x coordinate is 2, y is 0. So let's check out whether 2 comma 0 satisfies this equation. 10 times 2 minus 4 times 0. 10 times 2 is a 20, minus 0 is a 20. So LHS is a 20, RHS is a 20. So you pick any point. Let's pick a negative coordinates, right? What is the value of x? X is equal to minus 3. What is the value of y? Y is equal to minus 12.5. Let's see if it works. 10 times minus 3 is what when I plug in the value of x. Minus 4 times minus 12.5 is what we have. 10 into minus 3 is a minus 30. Minus of minus will make it as plus. 4 into 12.5 is a 50. So the value of LHS equals 20, which is what the RHS is. So you pick any point on this line, not just what we have got integer values. It could be this point. It could be this point. You pick the coordinates of any point on the line and substitute it in this equation. It will satisfy this equation. The second part of substituting, you realize we picked this point 2 comma 5. X coordinate is 2, y coordinate is 5. So this is a point whose coordinates are 2 comma 5. The orange is the line that we are talking about. Is this point lying on the line? This point is not lying on the line, which is why it did not satisfy the equation. So what does a linear equation in two variable mean? A linear equation in two variable represents a straight line. If there is a value of x and y that satisfies this equation, what does that mean? That's a coordinate of a point lying on that straight line. If the values of x and y do not satisfy the equation, then it means that we are talking about coordinates of a point which are not lying. The point is not lying on the straight line. So this is a geometric representation of a straight line and what a value that satisfies this equation means. Let's move on from here. We looked at what happens for one line. This entire chapter is about a pair of linear equations. So let's pick the generalized form. We said generalized form of one linear equation in two variables is ax plus by plus c equals 0. We did it a couple of slides earlier. If you have two equations, just take one example, something very simple, 3x plus 4y equals 5 or 3x plus 4y plus 5 equals 0. Let's pick something 10x plus 12y plus 90 equals 0. Right? X, y and equals 0 are all common. What is changing? This 3, 4, 5 is different here. 10, 12, 90 is a different set of values here. So if you had to represent it, this A, B and C are going to be different when you're talking about a pair of linear equations. So you're going to be writing them as A1x plus B1y plus C1 equals 0 and A2x plus B2y plus C2 equals 0. Now what do they represent geometrically? A1x plus B1y plus C1 is a straight line. A2x plus B2y plus C2 is also a straight line. So we'll get one straight line for this. We're going to get another straight line for it. So these two, a pair of linear equations, when you look at what is the geometrical significance or how will they be, what will they look like when you plot them on a graph sheet, you're essentially going to get a set of two straight lines, a pair of straight lines. There are three possibilities that arise. One is this. These two straight lines could intersect in this fashion. This could be equation 1. This is a straight line represented by equation 2. They intersect at one point. There is another possibility. If I'm talking about two straight lines, those two straight lines could very well be parallel lines. And there's a third possibility, which is these two lines could be coincident. One line is on top of the other. They're actually one and the same line. They're not two different lines. The gray line and the orange line are one and the same. Let's make a couple of inferences here for each of these possibilities. In this case, these two straight lines intersect at one point. There is only one point common to both these lines. Parallel lines never meet is a saying. So there is absolutely no point common to these two lines. In this case, any point you pick is going to be a point on the first line, which is a black line, and a point on the second line, which is an orange line. So all points are common to both these lines. So I made one inference based on the number of common points. One common point, zero common point, infinite common points. Let's start with this. Two parallel lines. If we know that two lines are parallel, then we can infer that the slopes of those two lines will be equal. Parallel lines have the same slope. Two coincident lines have everything same. They're one and the same line. Obviously, their slopes are also going to be equal. So if the slopes of two lines are equal, they will either be parallel lines as in possibility 2, or as in possibility 3, they could be coincident lines. So slopes are equal, we have two possibilities. Could be parallel, could be coincident. So the converse is going to be true if these two straight lines are intersecting at one point. These two lines are not parallel, these two lines are not coincident, which means their slopes cannot be equal. So if two straight lines intersect at one point, then the slopes of the lines intersecting at one point will not be equal. Quickly summarize it. There are three possibilities when we have equations of two straight lines. They could intersect at one point, in which case they'll have different slopes. They could intersect at no point, which is the case when they are parallel lines. In that case, their slopes will be equal. They could be coincident lines, which means they'll be intersecting at infinite points. In that case, also their slopes are going to be equal. So two possibilities where the slopes are equal. In this case, the slope is not equal. We're going to take this possibility 1 to the next video in part 2. In part 2, we're going to be looking at the possibility where they intersect at one point, or the condition for a unique solution. And we'll run through all of these parts in the next video. Before you leave, do two things. Sign up at online.maxtute.com and get started with your CBSE Class 10 Maths coaching. It takes all of 5 minutes and 3 steps to get started. Second thing I would like you to do is basically subscribe to this channel, youtube.com/maxtute, and spread the word among your friends and classmates.